In this video we go to look at how does a Falcon 9 reusable rocket works. And we look at all the components and procedures of the Falcon 9 rocket and also explore the Falcon 9 journey into space. Let's jump into the video. Falcon 9 is the world's first orbital-class reusable rocket. Designed and manufactured by SpaceX. SpaceX is an American aerospace manufacturer and space transportation services. It was founded in 2002 by Elon Musk with the goal of reducing space transportation costs. Falcon 9 is a partially reusable two-stage to-orbit medium-lift launch vehicle. Reusability allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of SpaceX. Both the first and second stages are powered by SpaceX Merlin engines. The Merlin engine is powered by liquid fuel and oxidizer. Both of them burn together and generate thrust. During the first stage, the Merlin engines powered by liquid fuel and liquid oxidizer. Both fuel and oxidizer are partially mixed with each other, and the combustion takes place. The first stage having 9 Merlin engines. Each of them generates 845 kilonewtons of thrust and 981 kilonewtons of thrust in vacuum. This is the payload section of the rocket. The main part of the rocket is the payload. It contains the Dragon capsule. The Dragon is a class of reusable spacecraft. It is the only spacecraft currently flying that is capable of returning significant amounts of cargo to Earth and is the first private spacecraft to take humans to the space station. It has 2 variants: Crew Dragon and Cargo Dragon. Let's see how this works on the day of the launch. The first stage of the rocket had 2 tanks. It contains a liquid oxidizer and fuel. Both of these components are pumped into the Merlin engine. Then the 9 Merlin engines are ignited. Each of the engines generates 845 kilonewtons of thrust. That means 7,607 kilonewtons of total thrust. This thrust propels the rocket 1 minute and 10 seconds after liftoff. The Falcon 9 reaches supersonic speed. Approximately 158 seconds into flight, the first stage engines are shut down. This event is known as the main engine cutoff. With the help of the cold gas thruster, the first stages fell into the Earth. 8 seconds later, the second stage, single Merlin vacuum engine ignites to begin a 7-minute burn that brings Falcon 9 and Dragon into low Earth orbit. 40 seconds after second stage ignition, Dragon's protective nose cone will be separated. 9 minutes and 37 seconds after launch, the second stage engine cuts off. 35 seconds later, the Dragon separates from Falcon 9's second stage and achieves its preliminary orbit as Dragon chases the space station. After a few seconds, nose cap of the Dragon will be opened. As Dragon chases the space station, the spacecraft will establish UHF communication using its COTS ultra-high-frequency communication unit. The Dragon will stay on the space station. The crew will work over the next 4 weeks to unload Dragon's payload and reload it with cargo that Dragon will bring back to Earth. Here is the question: how does the Falcon 9 return back to Earth and land successfully on ground? Let's explore it. The booster is programmed to follow a precise flight path return back to Earth. And it must autonomously perform a series of controlled maneuvers in order to maintain that path and land vertically on the landing pad. There are 3 types of flight controls: cold gas thrusters, grid fins, and reignitable engines. The Falcon 9 is equipped with a total of 8 nitrogen cold gas thrusters that is mounted towards the top of the first stage. There is 1 pot on each side of the rocket, each containing 4 thrusters. The cold gas thrusters are used to control the orientation of the rocket, which uses the expansion of a pressurized gas to generate thrust. This thrust controls the orientation of the rocket. They are particularly useful for the flip maneuver after stage separation. Number 2. Deployable grid fins. 4 titanium grid fins are mounted at the top of the first stage booster. The fins are aerodynamic control surface that used for precise control of the rocket's position and orientation prior to landing. The 4 grid fins alone are primarily responsible for the incredible 10-meter landing accuracy. Number 3. Reignitable engine. since the first stage must perform 3 separate burn after stage separation. It is necessary for the main rocket engines to be reignitable. The engines of the first stage booster have therefore been designed so they can reignite. Let's explore the guidance system of the Falcon 9 rocket. The Falcon 9 is equipped with an inertial navigation system and global positioning system. Inertial navigation system that uses several types of sensors to measure the position, orientation, and velocity of the booster. A global positioning system is also used to measure the geolocation. The onboard computer receives data from the inertial navigation system and global positioning system in real time and checks that information against a pre-programmed flight path. If the computer detects any deviations from the flight path, then instructs the rocket to adjust its orientation and velocity as necessary. Deployable landing legs. In order to perform vertical landing, the Falcon 9 is equipped with 4 lightweight landing legs. Each leg is constructed from carbon fiber and aluminum and contains an impact attenuator for particularly hard landings. The total span of the deployed landing gear is approximately 18 meters. And the entire landing system weighs less than 2,100 kilograms. After its mission at the orbital laboratory is completed, Mission Control Houston will send commands to detach Dragon from the space station, and then the crew will release the vehicle via commands from the crew command panel. Approximately 5 hours after Dragon leaves the station, it will conduct its deorbit burn, which lasts up to 10 minutes. It takes about 30 minutes for Dragon to re-enter the Earth's atmosphere. Then it's splashed down in the Pacific Ocean.